Hello, everyone. I appreciate you tuning in. My name is John McCullough. You know, there are a lot of unhealthy things out there that we all take part in because we like it. Big Macs, Velveeta cheese, binge-watching Netflix, keeping up with the Kardashians. The list goes on. Today, though, I want to talk to you about beer. Now, we could spend hours talking about beer, the different types, flavors, and what beer complements what food, but we're actually going to try and figure out if it is possible to prevent something called Korsakoff Syndrome, which is a syndrome that results from thiamine deficiency, which could be caused by alcohol abuse. This IRB proposal will outline all the things that need to be considered, such as the importance of this research, previous literature on the topic, methods for the study, and expected results. So starting off, let's talk about thiamine. Thiamin, or vitamin B1, is a water-soluble vitamin that is a cofactor in macronutrient metabolism, such as carbohydrates. In addition to its role in its biologically active form, it also acts as a coenzyme and non-coenzyme. The human body does not synthesize thiamin, so the best source of thiamin are meats such as lean cuts of pork, there's yeast, grains, cereals, and vegetables such as legumes or potatoes. With regard to vegetables, it is important to note that prolonged cooking, specifically in water, can diminish the thiamine, as it is thermosensitive and hydrosoluble. Thiamine deficiency is nothing to scoff at, as it can cause multiple diseases, such as beriberi. This can affect the muscles, heart, nerves, and digestive system. In addition to this, and where our focus will be, there is Wernicke-Korsakoff Syndrome, which are two separate diseases that can cause brain damage due to thiamine deficiency. It can also sometimes occur in individuals with the chronic illness or after weight loss surgery. The most common occurrence, however, happens in individuals that have alcohol use disorder. So what is Korsakoff Syndrome? I suppose we should start by talking about its younger sibling, Wernicke's encephalopathy. Wernicke's is a life-threatening illness that is characterized by ophthalmoparesis, with nystagmus, ataxia, and confusion. In other words, it really messes up the human brain. Just like Korsakoff Syndrome, it mainly affects the central nervous system. This is where alcohol comes in. Currently, the science is sound with regard to alcohol hindering thiamine transport, absorption, and metabolism in the body. You can see how having alcohol use disorder or alcoholism may set off this cascading effect of thiamine deficiency, Wernicke's, and finally, Korsakoff Syndrome. Korsakoff Syndrome has been defined many times in several different ways. For example, in 1971 by Victor and Adams as an abnormal mental state in which memory and learning are affected out of all proportions to other cognitive functions in an otherwise alert and responsive patient. It has all the same effects as Wernicke's, but it is more severe and it's permanent. Individuals will have an inability to form new memories, potentially severe loss of memory, confabulation, and hallucinations. There is currently no treatment for Korsakoff Syndrome. Right now, we can only treat Wernicke's by giving those affected by it 500 milligrams of thiamine 3 times daily, parenterally. So thiamine plays a critical role for the brain. It's involved with nerve function, retinal neurons, and promotes survival of hippocampal neurons in high cell density cultures. We know that thiamine supports the brain, but we do not have any literature that explores and dissects the human brain for the effects. But there is some about animals. For example, in a study that was conducted on rats in 2015, 18 to 20 Worcester male rats that were 200 to 250 grams were killed and decapitated, and their brains were extracted, cleaned, and experimented on to understand the molecular mechanisms of the non-coenzyme action of thiamine in the brain. This is significant because it showed that thiamine is not only a coenzyme for acetyl-CoA production, but also an allosteric regulator of acetyl-CoA metabolism, including regulatory acetylation and proteins and acetylcholine biosynthesis. Furthermore, the results of the study showed how a thiamine deficiency plays a role in neurodegeneration. Regarding Wernicke-Korsakoff Syndrome, a 2019 study concluded that thiamine is mentioned in most of the research about the topic. So there are a lot of problems here. We know that Wernicke's preludes Korsakoff, but 80% of cases are underdiagnosed, not to mention that alcohol in the United States is a real concern. For people ages 12 and older, nearly 15 million had alcohol use disorder, and high-intensity drinking is an emerging trend as well. High-intensity drinking is defined as consuming alcohol at levels that are 2 or more times the gender-specific binge drinking thresholds. Keeping this in mind, it is reasonable to assume that as the high-intensity drinking continues to rise, the prevalence of Korsakoff Syndrome will increase as well. In addition, there is strong evidence that alcoholism runs in families. About 1/4 of sons of alcoholics become alcoholics themselves, while daughters of alcoholics develop this disease about 5% of the time. Diagnosing alcoholism can be difficult as well because the patients may remain functional or may not be experiencing any withdrawal symptoms. This information only further illustrates that instances of Korsakoff syndrome will continue to be a constant issue for those individuals that suffer from alcoholism. So, let's take alcohol out of the equation for a moment. For reference, the recommended daily intake of thiamine for ages 14 and up is 1.2 milligrams for men and 1.0 to 1.1 in women. This is not that much. In fact, the average daily intake of thiamine from food supplements is 4.89 milligrams in men and 4.90 milligrams in women, and it's difficult to get thiamine toxicity as it is water soluble. Now, if we were to bring alcohol and alcoholism back into this conversation, you can understand the impact that it has. So, what is being done to solve this problem? Almost nothing. Some studies aim to add thiamine to food that does not normally have thiamine in it, such as rice. It is a process called biofortification, and it doesn't really work yet. But the overall principle could be something. What if instead of adding thiamine to food, it was added to beer? This is the premise of this IRB proposal. Can the addition of thiamine to beer reduce complications from alcoholism, such as with Korsakoff syndrome? The null hypothesis is this. The addition of thiamine to beer will not significantly decrease the incidence of Korsakoff syndrome. And here's how it's all going to work. This is a double-blind randomized controlled test so as to prevent any bias for the participants and those conducting the study. To start, this study will require 2 groups of adults aged 21 to 25. There will need to be a total of 210 participants with 105 in each group. For the purposes of this study, attrition will be estimated at about 10%. Both male and female subjects will be recruited for the duration of the study. In order to be accepted, participants must have a normal body mass index and have no history of alcohol abuse. Advertisement for the study will be done at the University of Maine at Orono in the form of flyers and contacting professors in the health departments to encourage their students to join. There are incentives to joining, such as doing something of interest, contributing towards the advancement of science, and a $100 check upon completion of the study. Pre-qualification also includes needing to fill out a survey that asks questions such as, have you ever had a problem with alcohol abuse? Do you have hepatitis? Or do you have liver disease? This will be part of the exclusion criteria. After filling out a consent form, these answers will need to be confirmed via hepatic function test. All of these are necessary to not put any participants at a health risk. The study will be conducted at the UMaine campus over the students' fall break. Students will be required to stay at the campus facilities for the duration. It will last 3 days, and all meals will be regulated according to the MyPlate recommendations. There will be 2 groups. The test group will be drinking beer that is fortified with 0.5 milligrams of thiamine, and the control group will get beer without thiamine. Here's where things are going to get interesting. Each participant will be asked to consume 3 beers over a 2-hour session following lunch. This beer will ideally be brewed and provided by Orono Brewing Company, as they are the popular and local brewery near the UMaine campus. At the end of each day, all participants will have their blood drawn to measure their thiamine levels. At this point, they will complete a verbal check-in to see how they are doing and checking on their overall condition. All data will be recorded using spreadsheets and stored in the UMaine and UNE servers until completion of the study and the data analysis. These will be locked behind a 2-factor authentication process and will eventually be destroyed. There are some risks to this being part of the study. Blood draws may cause hematoma on participants' arms. As they will be consuming alcohol, there will be injuries, or there could be injuries from loss of balance. There will be headaches, stomach aches, and dehydration, although water is readily available and encouraged. Things that will be analyzed will include anthropometrics, body mass index, and thiamine levels in the blood. The main thing that needs to be scrutinized is if adding 0.5 milligrams of thiamine to beer will yield a net increase in the body and how it differs from the control group, if it does at all. A chi-square test will be used to interpret the aggregate data and analyze the differences between the two groups. So it's difficult to say what the expected results of this study would be. However, the addition of thiamine to this test subject's beer has a reasonable chance to improve their overall levels of thiamine in the body. The findings of this study could provide a prevention method for Korsakoff syndrome in those with alcoholism. That being said, there are challenges to this study. An ideal population to target in this study would be individuals that have alcoholism, as they are the population that would stand to benefit from this research. Although, having alcoholics participate in a study in which they're consuming alcohol would be potentially dangerous to their condition and would require much heavier monitoring for everyone. There is not much literature on this topic as well, so it is impossible to know if 0.5 milligrams is enough to cause a significant increase in thiamine levels, although there is some precedence to use it as a starting point. Keeping all that in mind, the population that will be used for this study is still ideal, and the results can be used to infer whether it would work with alcoholics. This study will provide a useful framework for future research. And in conclusion, Korsakoff syndrome is a serious medical condition that has very few prevention methods. For those with alcoholism, and this study breaks into new territory of supplementation. While it has its limits, this study will provide insight and a possible solution to a problem that has been around for decades. And here are all the references for the presentation, and I hope you enjoyed it. Thank you.